Everything supposedly began with a huge Big Bang, and our universe has been expanding ever since. But what is beyond the edge of the universe? If everything originated from a point that is now expanding, there must be an edge to the universe. And if there is an edge, there must logically be something beyond it. Science provides some exciting approaches to bring us closer to the ultimate end of our world and the afterlife. But which one is right? People used to think that the world ended at the horizon. Anyone who got there would inevitably fall off the edge of the world and disappear at some point. However, a few curious people ventured further and realized that the edge of the world moves with them in a fascinating way. But we only realize that the world was round thousands of years ago. The idea of the end of the world persisted for a long time. The Earth was a disk, and again the idea was that whoever came too close to the edge would be lost forever. When the land masses were better explored, people thought that this end lay beyond the seas, and it was better not to sail too far out. Only Columbus realized that this was complete nonsense and sailed to America. Since then, it has dawned on people that their Earth is a sphere without real beginnings and ends. In any case, nobody gets lost, they can run as far as they like. It's the same with the universe. Today we imagine an end at which everything must be over, and void or nothingness comes. But is that really the case? The universe is expanding to where it sounds crazy, but scientists currently believe they can prove that our now gigantic universe originated from a point that was smaller than a seed. Since then, the universe has been expanding. Most scientists agree that the universe is not expanding within a space that was already there before the Big Bang, but that space is created by and with expansion. Nevertheless, in our imagination, this must happen within some kind of space or medium. What that could be, we don't know at the moment. We also don't really know whether the Big Bang really happened, and we also don't know how big the universe really is. In practical terms, this means that we cannot see either the temporal or spatial end of the universe. Then theoretically, we can't see beyond the edges either, or can we? Scientists are trying to approach the problem of the non-visibility of the edge in other ways. The observable universe is the part of the universe that we can recognize and study with our current technological means and scientific methods. It is defined by the maximum possible distance from which light and other electromagnetic radiation has reached us since the Big Bang. This limit is determined by the finite speed of light, which according to Einstein's theory of relativity is approximately 299,792,458 meters per second. Hubble assumed that beyond this horizon, light expands so quickly due to cosmic expansion that it can never reach us. This was calculated using the Hubble constant, which indicates the rate of expansion in relation to distance. Current estimates of the Hubble constant are around 70 kilometers per second per megaparsec, with 1 megaparsec corresponding to around 3.26 million light-years. Based on this data, obtained from observations within the visible universe, researchers draw conclusions around the areas outside the visible universe. However, this does not necessarily lead to truly consistent results. The Hubble horizon is just a theory that can be mathematically understood in some way, but has not been proven by concrete observations. We do not yet know whether the Hubble constant behaves in the same way everywhere in the cosmos, nor do we know what is really behind the Hubble horizon. Light is another key to approaching the edge of the universe. The speed of light is a fundamental limit to our perception of the universe. The observable universe is said to be about 13.8 billion years old, so one might assume that the observable universe has a radius of 13.8 billion light-years. But this is not true because the universe has expanded since the Big Bang. Which means that the observable universe actually has a radius of around 46.5 billion light-years, and therefore a total diameter of over 90 billion light-years. This apparent contradiction arises because we see the light from objects that were much closer at the time the light was emitted than they are now, and we see the past. This is because the light shows us images from space that have long since passed. Even the light from Alpha Centauri takes more than 4 years to reach us, and so we can only ever see the star as it looked 4 years ago. This quickly makes it clear that we cannot actually see the universe as it is at the moment. We see a play of light consisting of movement and expansion in both a temporal and spatial sense, which took place in the past. With the current state of technology, we can practically never see all the way to the edge, and calculations are not that easy either, as we can only ever look from the perspective of our Earth. You are probably familiar with the effect that indistinct or ambiguous objects can be recognized much better if you change your perspective or walk around the object you want to identify. Unfortunately, we can't do that with space just yet. We would either have to make space travel possible, send probes to distant places in space, or develop a kind of clairvoyance that would allow us to see the cosmos in its entirety. Do you remember the beginning of the video and our little excursion into the earthly past? How silly the views of people from times long past seem to us today. There's a good chance that our descendants will think very similarly about us. They will probably be amazed at how simple-minded people of the 21st century were when they were looking for an edge to the universe and something beyond it. These people could live in a world in which the multiverse is no longer pure theory, but has become a fascinating and far-reaching truth. The hypothesis today is that our universe is just one of many possible universes that together form a multiverse. According to this hypothesis, a new universe would begin beyond the edge of our universe, or our universe would be located within another one. Or the people of the future may even live in a quantum multiverse, in which they have become aware that each person can create realities and entire worlds. This would mean that the boundaries of our world would dissolve, and that even within the world we know today as Earth, there would be many different worlds and truths that partially touch and overlap. The Everett Many Worlds interpretation of reality allows that one day we might simply manifest the boundaries away. We could decide that the Earth is no longer a sphere and even bring our world together with other worlds using only our mental creativity. In this model, reality would be nothing more than an expandable and malleable mass, and the question of the end of the universe and what lies beyond would have long since been settled. If string theory turns out to be true one day, we will live in a world in which the basic building blocks of the universe are tiny vibrating strings. Our universe would then have additional dimensions, and the four known spacetime dimensions would also be a thing of the past. Behind what we know today as the universe, there would then very probably be further dimensions whose appearance we Earthlings of the 21st century would find difficult to understand. All these ideas take us into worlds of temporal, spatial, and dimensional infinity. The question of nothingness remains. Do you?